Before we begin, pause for a moment and think about the last toy you remember loving. Not the last app you downloaded, not the last screen you stared into, but the last object that lived on the floor, that stayed where you left it, that did not need to be charged before it could become something else. Think about how quiet that room was and how loud your imagination felt inside it. This story begins there, in that quiet, at the exact moment when play stopped being patient and technology stopped being invisible. It is a story about why one of the most successful toy companies in history chose to go forward by appearing to go backward. Why, in an age of glowing screens and listening devices, it decided to hide a computer inside a brick and pretend it was nothing special at all. Stay with this story, because what looks like a small design decision is actually a blueprint for how technology might finally learn to leave us alone. Silence used to be the default setting of childhood. Not perfect silence, not a museum hush, but the kind of ordinary quiet where imagination can make its own noise. A room with toys on the floor, a window half open, the small scratch of plastic against wood, the low mutter of a kid narrating a battle that only exists because they decided it does. For most of the history of play, the loudest machine in the room was the child. Then slowly, the hierarchy flipped. In the last decade, play has been redesigned around glow, bright rectangles in small hands, faces lit from below in dark rooms, toys that arrived with instructions that began not with build, but with download. Little robots that could not move until they were updated. Dolls that could not speak until they connected. Games that did not begin with curiosity, but with a login screen, a permissions prompt, a spinner.
The new generation of play is here.
You can tell yourself this is progress because it looks like progress. It has menus and icons and voice assistants. It resembles the adult world, which is to say, it resembles money. But in the private economy of a child, where attention is the only currency that matters, friction is a tax, and waiting is a deal breaker. The more toys began to behave like apps, the more play began to inherit the same fatigue that adults feel when technology asks for one more step, one more password, one more update, one more moment of patience that it has not earned. This is the paradox at the center of modern childhood. We built an industry around engagement, then wondered why kids looked tired. We built toys that demanded attention, then worried when children could not look away. We treated screens as the easiest bridge between plastic and possibility, then watched the bridge become the destination. The physical thing became a peripheral for the digital one. The toy became an accessory. The brick became a controller. Then in early 2026, on a stage designed to worship the future, one of the biggest companies in the world did something that looked on the surface like a retreat. No headset, no anthropomorphic assistant, no tablet-first control scheme, just a brick, ordinary in silhouette, familiar in weight, almost insulting in its simplicity. Sort of thing you could mistake for a prop in a joke about the tech industry losing its mind. They called it the Smart Brick. The name was almost too direct, as if the point was not to impress you with poetry, but to place a stake in the ground. This is a standard, not a stunt. This is infrastructure, not a novelty. It is not a new toy category trying to steal your child's attention. It is an attempt to give attention back. What made the Smart Brick unsettling was not what it offered, but what it refused. It did not present itself as a screen. It did not require you to hold a phone to make it work. It did not ask for a Wi-Fi password. It did not ask for a child's birthday. It did not quietly open a door to the internet and invite the world into the room. It looked dumb in the way that objects used to look before everything grew a digital face. But dumbness was the disguise. The argument, implicit and confident, was that the future of digital play was not more visible technology. It was invisible technology. A computer that behaves like plastic. A network that behaves like touch. A system that insists the most important interface is still the human hand. To understand why that mattered, you have to understand how we got here. Lego's relationship with technology is older and messier than the popular story suggests. It is not a company that discovered electronics recently. It is a company that has been trying to fold computation into the brick for decades, often with sincerity, sometimes with awkwardness, and always with a clear fear of breaking the one promise its brand cannot survive without. The promise that the brick lasts, that it does not expire, that a child can inherit a pile of pieces from an older sibling and still make something real. The smart brick arrives as an answer to a question the industry has been asking the wrong way. For years, the question was, how do we make toys digital? The smart brick reframes it. How do we make digital things behave like toys? How do we make electronics adopt the ethics of plastic? How do we make the computer disappear, not because it is weak, but because it is finally strong enough to get out of the way? Inside the smart brick is the kind of engineering you do not do for a gimmick. Buried inside a classic ABS shell is a custom piece of silicon so small it borders on the absurd. A chip built not to run a general operating system and not to pretend to be a phone, but to do a narrow set of tasks very well. Power management, networking, sensor fusion, low latency response, and the translation of physical context into behavior. It is less like a phone processor and more like a little nervous system. The brick does not want to be a computer you can see. It wants to be a body that can feel. This is where Lego's philosophy becomes clear. The smart brick is not sold as a gadget with a menu of features. It is sold as an extension of a system in which meaning comes from arrangement. Lego has always been a language of structure. Its genius is not any single set, but the grammar that allows sets to speak to each other. Two bricks connect, and the connection is not a theme, it is a relationship. A door hinges, a wheel turns, a tower stands because the clutch power is reliable and the tolerances are ruthless. For decades, the digital layer threatened to break that grammar because it introduced new points of failure. A motor brick that cannot charge. A hub that only speaks to certain elements. A software update that makes last year's set incompatible with this year's phone. A server shutdown that turns a once magical toy into a mute ornament. Every digital feature arrived with an expiration date. Plastic, for all its environmental complexity and cultural debate, has one advantage in the imagination. It is patient. It waits for you. It does not demand maintenance. The smart brick is a bet that digital can learn that patience, that the next step is not to make children more fluent in screens, but to make screens less necessary. That the most advanced toy is the one that can be played with in a living room where the Wi-Fi is down, on a long road trip, in a cabin, in a place where a child's world is larger than a router. This sounds like a marketing story, the kind of narrative companies love to tell about themselves. But there is a darker backstory underneath it. And it matters because it explains why LEGO chose this particular path. If you want to understand why the smart brick is built like a fortress, you need to remember the mid-2010s, when the toy industry embraced connectivity with the enthusiasm of a gold rush and the discipline of a backyard startup. It was the era of surveillance toys, though nobody called them that at the time. They were called educational companions and interactive friends. They promised language learning, social development, safer communication. They offered microphones, sometimes cameras, often cloud services that would store recordings, process voice, learn user preferences. The problem was not the ambition. The problem was the infrastructure. Many of these companies treated security like a feature you could add later, and then later arrived as a headline. Parents learned in the most brutal way that if a toy connects to the internet, it can connect to anything. Databases were left exposed. Audio recordings were stored without adequate protection. Account systems were built with weak authentication. Entire families were dragged into a lesson in how the modern internet punishes carelessness. A child's bedroom became unintentionally part of the internet of vulnerabilities. You do not need to be paranoid to feel the weight of that. You simply need to imagine the emotional contract a parent signs when they place something in a child's hands. Toys are intimate objects. They live on floors and in beds. They sit beside nightlights. They end up under pillows. They absorb the logic of the home, which is to say, they absorb trust. So when LEGO decided to build a digital standard that would live inside a brick, it could not afford to inherit the sins of connected gadgets. It could not afford to ship a product that would become a case study in how not to secure devices meant for children. It could not afford a system that quietly asked for personal data because the brand's entire value is built on a specific type of innocence. A brick is supposed to be safe by default. A brick is supposed to be boring to hackers. A brick is supposed to be the last object in your home that feels like it belongs to an older, simpler era. This is why the smart brick's most radical feature is absence. It has no Wi-Fi radio. It cannot connect to the internet directly. There is no cloud account required to make it function. No login, no camera, no always-on microphone meant to capture speech. The brick lives local by design. When it communicates, it does so only with other bricks in the room, in a closed mesh that does not depend on a server's uptime. This is not just a privacy gesture. It is a reliability gesture. It is LEGO declaring that for children's toys, the safest network is the one that never leaves the floor. Of course, you can't build interactive experiences without sensors. The brick needs to feel in some way what the child is doing. That introduces a problem that every modern product faces. How do you add sensitivity without turning sensitivity into surveillance? How do you let a toy react to sound without letting it listen? The smart brick's approach, in the philosophy described by its defenders, is to treat sound as physics rather than language. A microphone can be used as a recorder, but it can also be used as a pressure sensor. That distinction matters. A device that measures the volume of a clap is not the same as a device that tries to interpret your words. A device that detects a pattern of taps is not the same as a device that stores voice. The idea, as it is framed, is brutally simple. The brick senses energy, not content. It reacts to the fact that a loud sound happened, not to what was said. It turns the room into an instrument without turning the room into data. It offers interactivity without memory. In a world where so many devices are designed to capture and keep, this is a different ethic. The brick is meant to forget. It is meant to be present, then silent again. The ethics of this design are inseparable from its cultural context. Parents today are not simply shopping for toys. They are shopping for boundaries. They are trying to purchase a pocket of childhood that is not colonized by the same attention economy that governs everything else. In that environment, privacy is not an abstract legal idea. It is a form of calm. It is the right to let a child play without feeling like the room is also a platform. But privacy alone is not enough to make something feel magical. A toy can be safe and still be boring. The smart brick is built on a more ambitious claim, which is that digital features should amplify the physical world rather than compete with it. That the feedback should come from the object itself, not from a screen that turns the child into a spectator of their own play. This is where the smart brick becomes a reaction against what you could call the app trap. The app trap is the tendency of modern toys to require a smartphone or tablet as the true control surface. You build a thing, then you stare at glass to make it do anything. The physical build becomes a prop for the digital interface. And because screens are designed to be endlessly interesting, the toy loses. The child's eyes leave the bricks and do not return. Lego has experimented with this dynamic before, and the results have been uneven. There were moments of cleverness, moments where augmented reality could overlay ghosts on a build or bring a scene to life. But those moments carried a structural flaw. The best parts happened on the screen. The bricks became, in a sense, a QR code for software content. When the app was removed, the magic evaporated. The physical object remained, but its promise was amputated. The smart brick tries to reverse that. It insists that the brick is where the drama should live. If you build a cannon, the sound should come from the cannon. If you build a spaceship, the vibration should run through the hull. If a castle gate opens, the effect should resonate from the gate itself, not from a phone speaker on the couch. The feedback should be local, tactile, immediate. The toy should feel like it is responding to touch the way a living thing responds, without asking the child to translate everything through a device designed for adult attention. This idea that technology should disappear into a physical system is not entirely new. In the history of consumer electronics, the most successful technologies are often the ones that become invisible standards. Electricity ceased to be a novelty when it became infrastructure. Motors ceased to be a product category when they became components inside everyday machines. Wireless charging became normal only when it felt like placing an object down rather than engaging in a ritual. The smart brick wants to be that kind of standard, not because it is trying to dominate the tech conversation, but because it is trying to extend Lego's oldest principle into the digital era. The oldest principle is compatibility across time. A brick made decades ago still fits. The smart brick's real challenge is to make that true even when silicon is involved. That challenge becomes clearer if you look at the ghost that haunts this story. The line of products that made Lego a legend in programmable robotics and also taught the company hard lessons about friction. Mindstorm. In 1998, Lego did something genuinely risky. It gave children a programmable brain and let them build bodies for it. The original Mindstorm system, with its chunky gray brick and its ports and sensors, arrived as a kind of revolution in the toy aisle. It was a toy that assumed children could be engineers. It assumed a certain appetite for complexity. It offered an experience that did not just entertain, but invited experimentation. It was born from a partnership with the MIT Media Lab, and it carried the influence of educational thinkers who believed that learning happens best when children can build systems and see those systems behave. It created a cult. It also created a community that immediately hacked it, not out of malice, but out of love. The early Mindstorms era is remembered with a kind of romantic nostalgia because it represented a rare moment when a mainstream toy company accidentally released a platform. People wrote alternative firmware. They built forums. They created programming languages. They treated the brick as something closer to a small computer than a toy accessory. In classrooms, it became a gateway drug for robotics. In bedrooms, it became an invitation to stay up late. But Mindstorms also carried an early warning in its very shape. It required a computer. It required cables. It required patience. It made play conditional. The magic was there, but you had to climb a ladder to reach it. Over time, Lego improved the hardware. The brick evolved. The systems got more powerful. The NXT arrived. Then the EV3 with more processing power, more sophistication, more options. The robots became more capable. The software became more elaborate. The educational value in certain contexts increased. Yet something else was happening in the culture. The baseline expectation for responsiveness was changing. Smartphones trained us to expect instant gratification. Touchscreens trained children to expect that objects respond the moment you touch them. The entire world began to feel like it was built on immediate feedback loop. In that environment, Mindstorms began to feel slow. Not in terms of CPU cycles, but in terms of the human experience. You had to update firmware. You had to pair devices. You had to troubleshoot connection issues. And in the economy of childhood attention, every minute spent watching a progress bar is a minute where imagination finds something else to do. There is a simple line that explains the decline in a way that corporate statements never will. If it takes 20 minutes to update firmware, the kid is gone. This is not an insult to children. It is an observation about the nature of play. Play is a flow state. It is fragile. It can be broken by small interruptions. When a toy demands that you become a systems administrator before you can be a player, it is asking for the wrong kind of labor. It is asking for adult patience from a child who is not wrong to refuse. In late 2022, Lego announced that Mindstorms would be discontinued. It was the end of a remarkable line, one that had shaped a generation of builders and coders. Officially, it was described as a shift in focus, a redirection toward education platforms. But culturally, it was a signal. The consumer market for complex, programmable robotics was not growing the way it once seemed it would. The friction had won. What replaced Mindstorms was not a direct successor. Instead, there was a quiet period, a lull that felt like absence. Lego's other experiments with app-dependent play continued, but they did not fully solve the underlying problem. They still required screens. They still treated the phone as the nerve center. they still carried the risk of digital obsolescence. They still asked children to split attention between hands and glass. In that quiet period, the company's research focus shifted in a subtle way. Instead of asking how to make a smarter hub, it began asking how to remove the hub entirely. Instead of building a bigger brain, it began distributing intelligence into the bricks themselves. Instead of asking children to command machines through code, it began letting the physical arrangement of bricks become the programming language. This is a profound shift, and it reveals something about how Lego sees its own identity. Mindstorms was about explicit programming. You told the robot what to do. You wrote a sequence. You uploaded logic. The smart brick world is about implicit context. You do not tell the brick it is a thruster. You place it on a spaceship, and it behaves like one. You do not assign a port. You snap pieces together, and the system infers relationships. This seems like magic, and in a sense it is, but it is also a design philosophy that values immediacy over expressiveness. It prioritizes play flow over open-ended programming. It values the feeling of a toy being alive over the educational purity of teaching children to write code. That trade-off is the heart of what makes the smart brick controversial among certain adult fans. Mindstorms was beloved not just because it was fun, but because it empowered. It turned children into authors of behavior. It invited hacking. It celebrated tinkering. It was a gateway into engineering culture. The smart brick, by contrast, is designed to be sealed. It is designed to be robust, to survive drops, spills, chaos. It is designed to be reliable in a way that open systems often are not. It is designed to feel like a polished experience rather than a kit that expects you to build the software yourself. In the language of modern consumer products, it is curated. It is less like a programmable computer and more like a console where the experiences are authored for you. Lego's argument, implicit in the system's design, is that this is not a replacement for educational robotics. It is a new category. It is a standard meant to live inside ordinary sets, not a specialized platform meant for schools. It is meant to make the everyday brick feel responsive, not to teach children a programming language. It is built for the living room floor, not for the classroom lab. You can accept that argument or resist it, but you cannot deny that it reflects a sober understanding of what the market rewarded and what it punished. Complexity is punished in mass market toys. Setup friction is punished. App dependence is punished, even if it is tolerated. Parents do not want Christmas morning to begin with troubleshooting. They want toys that work. Though the smart brick's technology is designed to make the first experience feel like a spell. No pairing screens. No searching for devices. No PIN codes. No ritual. You connect bricks the way you always have by snapping them together, and the connection becomes digital. The physical click becomes a handshake. This is where BrickNet enters the story. BrickNet, as it is described in the project's language, is a local mesh network built on low-energy wireless communication, engineered specifically for the unpredictable environment of child play. The point is not simply that bricks can talk to each other. The point is how they talk. The world of adult tech is full of connection friction. The average person has a small museum of frustration in their daily life. Devices that fail to pair, speakers that forget phones, smart lights that blink as if pleading for attention. Adults tolerate it because adults have no choice. Children do have a choice. They can drop a toy and walk away. BrickNet is built to eliminate the ceremony. It assumes that if the toy cannot connect instantly, it should not connect at all. The mesh design is important because it removes the single point of failure that haunted earlier systems. There is no central hub that becomes a bottleneck. Every brick participates. Every brick is a node, a router, a small citizen, in a local republic of play. If one brick is out of range, the network routes around it. If a brick is removed, the system continues. The network behaves less like a corporate hierarchy and more like a swarm. Swarm is a word that can sound sinister, but in nature, it describes resilience. A school of fish can change direction without a leader because information is distributed. A flock of birds can move as one because each bird responds to its neighbors. The intelligence is emergent. That is, in a sense, what BrickNet is trying to emulate. Not in the sense that bricks are truly intelligent, but in the sense that behavior emerges from the relationships between nodes. One brick senses movement. Another brick plays a sound. Another brick changes light. The child does not need to understand the network topology. They only need to see the result. A gate opens and a dragon roars across the room, not because a phone issued a command, but because the bricks negotiated the event locally. This is more than convenience. It changes the feel of play. Latency matters. If you press a button and a sound plays a second later, you feel the seam between cause and effect. It feels like a machine. If the response is immediate, the brain begins to treat the object as alive. It becomes responsive in the way animals are responsive. You touch and it reacts. You act and it answers. The smart brick is designed around this psychological truth. It makes feedback loops tight enough that the child's brain does not need to translate the experience through rational thought. It just feels right. This is why the system is described as technology that respects the flow of play. It avoids the interruptions that break immersion. It avoids the moments that remind the child they're using a device. But the most radical part of this is that the system is meant to work without screens. That is not a nostalgic stance, not a moral panic about technology. It is a tactical design decision rooted in how children distribute attention. If the screen is present, it will dominate. The smart brick tries to make the physical world the center again. The feedback channels it uses are deliberately physical. Light is embedded in the brick. Sound resonates from the build itself. Haptics vibrate through the plastic. The object becomes its own user interface. Light in this model is not decoration. It is language. A warm flicker can make a torch feel alive. A pulsing red can signal damage. A slow breathing glow can signal calm or charging. The brick can communicate state without a single word of text. This matters because text requires literacy and because screens require focus. Light can be peripheral. A child can notice it while still building, while still acting in the world. Sound, too, is treated as texture rather than as a speaker in the corner of the room. When sound comes from the object, it anchors the imagination. A cannon sound coming from a cannon changes the way the child believes in the cannon. The sound becomes a property of the object rather than an external soundtrack. That is not a small difference. It changes the spatial logic of play. It makes the room feel like a stage where the set pieces have voices. Haptics are perhaps the most intimate channel because they communicate directly through the hand. A vibration can make a brick feel like it has a heartbeat. It can make an engine feel like it is idling inside the hull. It can make a lock feel like it clicks. These signals bypass the visual overload that modern children already have. They go straight into the body. Even the microphone, the most controversial sensor, is framed not as an ear, but as a way to let the environment become a controller. Blowing on a windmill, clapping to trigger a response, shouting to wake a dragon. These are ancient play behaviors, translated into digital triggers without being turned into recordings. All of this is meant to create a kind of emergent theater. A city where streetlights respond to a passing vehicle. A train set where gates lower automatically and alarms ripple across the layout. A castle where a gate opening triggers a chain of reactions. The magic is not in a script. The magic is in the system's ability to respond to what the child does in real time. This is the part of the story where the smart brick begins to resemble something larger than a toy, something closer to a platform. A platform is not defined by any single experience, but by the compatibility it enables. Lego's most powerful move, historically, was standardization. The 2x4 brick from the late 1950s became a kind of universal connector, allowing themes to mix and generations to share pieces. The smart brick is described as an attempt to create that kind of standard in the digital layer, a behavior layer that can be embedded into sets across themes, a communication layer that can persist across years, a power layer that can be shared across builds. Power is an underrated part of this because batteries were one of the most persistent sources of friction in electronic toys. Dead batteries end stories. Battery compartments, especially in children's toys, introduce maintenance and waste. If the smart brick is to behave like a normal brick, it cannot demand battery rituals. It cannot ask for screws and door panels and piles of disposable cells. So the system imagines a different approach. Sealed rechargeable power managed carefully for long idle life. Charged wirelessly through plates, the way modern devices charge when you place them down. The point is not simply convenience. The point is readiness. A toy that is always ready to play feels like a toy. A toy that requires a parent to fetch batteries feels like a device. All of this supports Lego's deeper attempt to solve digital obsolescence. Digital products die, apps disappear, servers shut down. The toy industry is littered with corpses of connected experiences that no longer function because the software layer evaporated. Families have closets full of toys that used to be magic but are now inert because the company moved on. That is the normal rhythm of technology, but it is incompatible with the culture of Lego, where old pieces are meant to remain alive. The smart brick's answer is local autonomy. If the intelligence lives inside the brick, and if the network is local, then the system does not depend on a cloud to exist. Even if the company disappears, the brick can still react. It can still talk to other bricks. It can still be itself. This is a crucial promise because it aligns digital behavior with the ethics of plastic. It makes the digital layer inherit the longevity of the physical layer as much as possible. This does not eliminate all concerns. A sealed battery, no matter how carefully engineered, will eventually age. A proprietary protocol is, by definition, closed. A system that updates can raise questions about ownership. People who loved Mindstorms for its hackability will look at a sealed brick and feel the loss of a certain kind of freedom. This is the developer's dilemma at the heart of the new standard. Open systems invite creativity and also invite chaos. Closed systems invite reliability and also invite suspicion. LEGO's history includes both impulses. Mindstorms began as a toy and became a platform because the community refused to treat it as closed. The company, after initial discomfort, learned to live with that and even to embrace it. The smart brick begins from the opposite stance. It begins with a curated experience, authored behaviors, reliable interactions that cannot be easily broken by a child who accidentally wipes firmware. The trade-off is that the ceiling is lower for advanced users. You cannot easily write your own logic the way you could in Mindstorms. You cannot as easily treat the brick as a general computer. LEGO's counter-argument is that this is not meant to replace that kind of platform. It is meant to standardize everyday play. It is meant to work in a child's room without a laptop. It is meant to remove the labor that once made programmable play feel like homework. Still, the tension remains, and it is not purely technical. It is cultural. It reflects a broader shift in how consumer products are designed. Many modern devices are sealed not only to protect users, but to protect the business model. They are ecosystems, not objects. They are experiences, not tools. People who grew up in the earlier internet, when hacking was a form of literacy, can feel alienated by that shift. The smart brick tries to soften this tension by emphasizing that even if the system is closed, it is not dependent. It does not require a subscription. It does not require a server. It does not turn ownership into a rental. It is closed, but self-contained. It is not a cloud service disguised as a brick. And yet the question remains whether the hacker community will accept that. Whether they will find ways in anyway. Whether LEGO will eventually offer a developer edition, an advanced kit that exposes more control for those who want it. History suggests that if a platform becomes popular enough, people will demand access. They will not be satisfied with magic. They will want to see the mechanism. There is an irony here. The smart brick is designed to make technology indistinguishable from play. But one of the oldest human impulses is to pull apart the thing that feels magical and understand it. And that impulse built engineering, it built science, it built the modern world. LEGO has always been a brand that encourages that impulse in physical form. The question is whether it will allow that impulse in digital form too. All of this brings us to the deeper cultural meaning of the smart brick, which has less to do with electronics and more to do with an evolving relationship between childhood and the attention economy. The smart brick is framed as an analog rebellion, not because it rejects digital capability, but because it rejects the logic of screens as the default interface. It suggests that the future might include more technology that hides itself, that respects human rhythms, that does not demand constant engagement. This is a subtle but important critique of Silicon Valley's dominant aesthetic. For years, the assumption was that the best interface is the one that captures your gaze, that a screen is the most flexible canvas for any experience, that the path to intelligence is through more display, more data, more connectivity. The toy industry followed that assumption because it felt like modernity and because it offered endless upsell possibilities through apps and content updates. Lego's move in this story is a rejection of that assumption. It is a bet that the most valuable digital experiences might be the ones that do not look digital, that the healthiest relationship between children and technology might be one where the technology is present but quiet, where it enhances the physical world rather than replacing it. There is a symbolism to this that goes beyond toys. A brick is one of the oldest metaphors for building. It is a unit of construction. It represents potential. It represents the human desire to make something stable from small pieces. When you embed invisible computation into a brick, you are not just making a toy smarter. You are making a statement about what kind of digital future you want. One where intelligence is distributed. One where systems are local. One where the interface is tactile. One where privacy is not an afterthought. One where the object does not beg for attention, but responds when invited. Of course, this is a marketing narrative too, and it is worth being skeptical. Companies do not make products out of pure philosophy. They respond to markets, regulations, competition, and internal pressures. But that does not mean the philosophy is fake. It means the philosophy is useful. It aligns with what the culture is demanding. Screen fatigue is real. Parents are anxious. Educators are conflicted. Children are overstimulated. The toy industry is saturated with products that promise smartness by adding screens, and those screens often become the whole experience. In that landscape, a brick that goes digital without screens stands out, not because it is anti-technology, but because it is anti-distraction. The smart brick, as this project imagines it, is the culmination of Lego learning from its own past. Mindstorms taught the company what empowerment looks like and what friction costs. App-dependent experiments taught it what happens when digital layers feel parasitic. Privacy scandals in the broader industry taught it that trust must be engineered, not claimed. The culture taught it that screens are powerful but exhausting. So the smart brick emerges as a synthesis, a standard rather than a theme, a platform rather than a toy line. A hidden infrastructure that can live inside future sets the way clutch power lives inside every stud. The test of that ambition is time. The real enemy of digital toys is not competition. It is decay. Digital rot. The slow death that occurs when software is abandoned, when platforms change, when apps vanish from stores, when servers shut down, when the toy becomes a fossil of a previous ecosystem. Lego's entire identity is built on resisting that kind of death. Bricks persist. Sets become heirlooms. Pieces mix across decades. The smart brick tries to make electronics behave that way too. It tries to make a device that can sit in a box for years and still wake up when you bring it back into the light. If that promise holds, it will represent something rare, a piece of consumer technology designed for longevity as a primary goal rather than as an accidental side effect. A digital standard designed to be passed down. There is also a sustainability layer to this story because The physical brick's longevity exists in tension with modern environmental concerns. Plastic lasts, and that is both its virtue and its curse. LEGO has spoken about transitioning to more sustainable materials over the coming years. A smart standard embedded in bricks complicates that transition because it adds electronics, batteries, materials that are harder to recycle. The project frames the smart brick as designed to be recyclable, but more importantly, designed to never need recycling because it will not be thrown away. This is a powerful rhetorical move. The most sustainable product is the one you do not discard. It is the one that stays in use. If the smart brick can extend the life of sets by making old builds feel alive again, then it could reduce the incentive to treat toys as disposable. It could make the pile of bricks in the closet feel relevant again. It also reinforces LEGO's most strategic advantage: backwards compatibility, the idea that you can take a set from the 1990s, add a smart brick, and suddenly the drawbridge has sound and the torches flicker, that you can take a spaceship from a decade ago and give it a heartbeat, that you can blend eras, that the old is not replaced by the new, but augmented by it. This is not just a technical feature. It is a cultural promise. It is LEGO telling families that their existing collections still matter, that the past is not obsolete, that the future can honor what came before. In the end, the smart brick's success will not be measured by how impressive the chip is or how clever the protocol sounds. It will be measured by whether children treat it like a normal brick, whether they forget it is smart, whether it becomes invisible in the way the best standards become invisible. Because that is the true goal of any standard. Not to be celebrated, but to disappear. The studs themselves are a standard, and no child pauses to admire them. They just build. They rely on the fact that the connection works. They rely on the fact that the pieces fit. They do not think about tolerances or patents or material science. They think about castles and cars and dragons. The smart brick wants to be that. A piece of deep engineering that fades into the background so completely that it stops being a feature and becomes an assumption. A quiet layer of intelligence that turns plastic into a responsive medium without demanding to be the center of attention. There is a final image that captures the spirit of the shift. A child's room at night. A floor covered in a sprawling creation that defies categories. Part castle, part spaceship, part robot. It contains pieces from old sets, pieces from new ones, maybe even a dusty gray relic from the Mindstorms era, a ghost of the time when LEGO tried to teach children to code by making them programmers of machines. Mixed in are the new bricks that glow softly, not like a screen that demands attention, but like embers that suggest life. The child is asleep. The build remains, not as a device waiting for an update, not as a product that needs a login, but as a thing that can exist quietly, ready to wake when the child wakes. In that quiet, the smart brick's philosophy becomes clear. The smartest technology is not the loudest. The smartest technology is the one that knows when to be quiet. If this vision holds, it will mark a subtle but meaningful turning point, not just for LEGO, but for the wider culture of consumer technology. It will suggest that the next wave of digital products might not look like screens at all, that they might hide in materials, that they might prioritize local autonomy over cloud dependency, that they might treat privacy as a baseline rather than a premium. that they might respect human attention rather than exploit it. And if you are a parent, or an older sibling, or simply someone watching childhood evolve in the glow of rectangles, you can see why that would feel like more than a new toy. It would feel like a small restoration, a return of agency to hands, a return of imagination to floors, a reminder that play does not need to be optimized. It needs to be possible. When Lego went digital without screens, it was not declaring war on technology. It was declaring loyalty to a specific kind of magic. The magic that happens when a child looks down at a pile of pieces and sees a world. The magic that begins not with a menu, but with a click. If you want more stories like this, stories about how culture reshapes technology and how technology reshapes culture, stay with this channel, subscribe, and keep building the deeper picture with me, one brick at a time. If this story made you see toys, technology, or even childhood a little differently, that is not an accident. These documentaries are about the hidden decisions behind familiar objects, the quiet pivots that shape culture long before we notice the results. If you want more long-form investigations like this, subscribe to the channel and turn this space into a place for deeper thinking, not faster scrolling. Share this episode with someone who still has a box of old bricks in a closet, or with someone raising a child in a world full of screens. And the next time you hear a piece of technology promised to change everything, ask yourself a simpler question. Does it make more noise, or does it know when to be quiet?